Guess we're going. Oh, the inconsistencies of WeVideo. Okay, so they're working on something. I forgot to start my video, so we already covered this. Okay, first of all, we're doing rational functions. Can you say rational functions? Good job. All right, now we're talking about just do your work, dudes. No, don't be looking at me. Get your answers. Okay, and then I covered this idea that and I don't want to bore you. Too late. Your voice does that all the time. Sorry, but you can have 0 divided by 1. That is an output of 0. Input, output. But so anytime you get 0 over number, that is 0. Anytime you get 0 in the denominator, that is not an output value. You get no 1 divided by 0 does not calculate. Your calculator would give you 0 divide by 0 error, I believe. We could say 0 in the slash there, it does not exist, so on and so forth. So then what we asked first thing is, where do you see these? Where are the points of discontinuity? Why this is a point of discontinuity is I have to pick up my pen to continue this graph. That's a discontinuity. It changes. My picture doesn't flow without interruption. I use the word interruption. This is a point. Jump. This is actually not called a jump. Um, that's called a removable discontinuity. We'll see that in a moment here. This is boink, and then jump. Nope, don't say jump, Mr. Samuelis. That's called something different. And then here we got a discontinuity here, and then a discontinuity from there to there. So at these locations, which I have there. Okay, so now what they're doing is matching these charts to these graphs. Input, say it, output. Okay, and then I'm going to probably do this up on the screen because this is really small written here. And then I'm going to come back to them and see if they got my answer. So I'm going to slide this here, move this here, and then see if you can see that screen. Looks awfully bright. Wow. It looks terrible. Doesn't that look like just a white thing right there? You ever look at this? Does this actually show up on the video?
You were standing right next to me.
Oh, is it my face that makes it a? No, it does. I screwed up the computer. Wow. I got some powers there, maybe some negative powers. Okay. All right. So here we go. Want to do this up here because this is a larger screen and I can see better. Did I freeze? What's going on here? Oh, it's because I froze. It's okay here. Oh, okay. I'm freaking out, man. All right. Okay. So here we go. Input, say it. So this one, I have an error at -1. So that means it could only be this one, or we're looking at this one, right? So it's one of two choices. So did you do that first little process of elimination? Okay. So the next thing is look at these outputs. 101. I'm gonna have to erase this because it kind of. What just happened? Did I just screw up everything? Oh, it's not this one. I moved this over here. Oh, old crazy guy. Can't remember things. Okay, but look after that error. -1.01. Ooh, something weird happened with the pen there. Comma 101. Now, I'm going to explain this when we get to the third one, how this actually happens. But that just means you're to the left of -1 right here, and your output went way up there. Got it? Okay, so -1.01, you're just left of. And then just to the right, -0.99, that's over here. I'm way down here. So this one, conveniently, was the first one. And this is what's weird, what happens. I'm going to explain this when we get to the third graph, which is the parent function. There should be math understanding here. I don't get it. No, you should. Now, why? Wait till I get to the third one, why this happens. So that's why this matches with this. And that's what they did. They got obnoxiously close to -1 and then plugged in negative. What fell? Did something just fall? Where? Oh, yeah, that tape never stays on the wall. I did some restructuring because I didn't want that poster on the board anymore. All right. And then this one's at 0 for an error. What has 0 for an error? Not this one. This one does. This one does. And that's about it. That's where we have our discontinuities. All right. Now I get to do this. Look just to the left of this. I get -100. So -0.01 comma, negative 100. That's not even at negative 100. I'm just giving you an idea. And actually, input, output, I can actually explain that. This one should make sense. Because 0.01, that gives me, that's just to the right of this here. Okay, well, this is the graph 1 over x. What is 1 over, 0.01 is 1 over 100. What's 1 over 1 over 100? Say that number right there. 100. So when I jump just to the right of 0, I'm getting an enormous x value. Weird. And this is what happens with what's called vertical asymptotes. I want you to draw that dotted line on this and understand what just happens to the right. That's the symmetry sound, whoever made that noise. That was illegal. All right, anyway. But you know what? This is an odd function, so go ahead and do that if you want. All right, that's legal. All right, so anyways, and then negative. She still doing the noise. Okay, then what if you plug in negative 100 or negative 0.01? Then you get negative 100. So this should make sense. So weird behavior is happening around the vertical asymptotes, and this will always be the case. We need to know that. On holes, you'll see why that's just a little brief interruption, and then the graph continues in the same pattern as it did before. Okay, and that's because something different is occurring. But anyway, that's this one, and I'll continue with this this idea. Now, negative 1 comma. Well, I only have one more left with the negative 1 asymptote, and sorry, negative 1. Yeah, as a thing being wrong. I just said that horribly. But look at these things. Just to the right and just to the left, they're both the same big numbers. That's because you're looking at the equation, something unique is happening with that. So that is this one. Did I point that to the right one? Yes. All right, then this one's 2 comma error. So that could be either this one or only that one, right? I guess that's my only choice. So 2 comma error, look at before and after. Big negative on the left, big positive on the right. Big positive on the right, big negative on the left. Okay, and that's what you see there, even though my pen kind of overwrote that. So that is 2 comma error. This one, this one might have 2. Because then this one also has 0 comma as an error. But look at this. These values are both close to negative 0.5. They're not extraordinarily different, like really large negative, really large positive. So this one also is this one because of these values right here, right before and right after. Input, say it. This is what makes me sad. Students that don't understand that, and I've said it since August. When did we start school? 16th, 17th, 18th, 19th? Since then! I don't even know what he means. What are you doing in here? All right, 1 comma error. 1 comma error. This one's really good. 0.99 right before, 1.1 right after. They're very close to being 2, right? So that's why the whole, can everyone say whole? The whole, the behavior before and after the whole are very, very close to the same thing. It's just a brief interruption, then the pattern continues. Vertical asymptotes, craziness occurs. Not craziness, but something that you've never seen before. Okay? All right, so we'll get that away, and I did those answers. Okay, so now I'm going to be really, really, really quick on this. You feel free to read. I am going to cancel something in your homework, though, for a moment. So everyone's like, oh, yes, yes, yes. Did you hear that? Everyone's, oh, thank goodness. I'm so abused with this homework. Okay, anyway, so what I'm going to cancel is something about the vertical asymptotes. But I want you to understand x equals k is a discontinuity when the graph is interrupted, like we've seen in these pictures. And I want you to understand all of this is related. A hole in the graph happens, and it's called a removable discontinuity. It's when our factors, you'll see in the equation. Let me just hold off right now. And actually, I'm going to go back up to the originals and make some points about it. I might do it right now. Here's what I'm going to cancel right now. This is not that you'll never have to do this, but we're going to cancel these limits for a second because I need you to have a little bit more knowledge of how those graphs even came about. We did the same thing with our AB students. We're actually a little bit ahead of them, of you guys, with rational functions, because we dived into some other stuff with you guys. You definitely have had more content. We just went into this quicker with them. But I want you to know more about graphing and how those graphs came about before we start talking about limits. I do want you to take note to self, though, that these pluses and minuses after mean something. It means to the left and to the right of a number. So I didn't say that even last hour. I kind of ignored the limits because I didn't want to do them right now because you don't know enough about graphing yet. I just want you to hammer one concept about rational functions. The idea of really not having zero in the denominator. And I'm going to go over that in a minute. And then these are all for the infinite discontinuities. These are when you have a vertical asymptote. So a vertical asymptote is called an infinite discontinuity. A hole in the graph is a removable discontinuity. Now, I started into the things down in the note, or like our notes next with the others, and then I went back up to these. I'm going to go back up to these and analyze some stuff. So let's look at this. All right, don't roll your eyes over here. Okay, all right. Now, here are the holes. Now, okay, so here's why we have. This is why we have vertical asymptotes here. Because what happens when you get zero in the denominator? What do you get? Undefined. The input, say it. There is no output. That's the problem. You're right by saying output. When I plug in -1 for x, I get -1 over 0, which is no output. But what's weird in a vertical asymptote is the behavior before and after. All right? Input output again, I can prove by plugging in those numbers why we get those weird big negatives and big positives. I proved it with the third one. All right, that's why we have x equals 0 as a vertical asymptote, because 1 over 0 is undefined. And then I proved just to the right big positives, just to the left big negatives. Which you really shouldn't say that. Small negatives is really what you should say. The more negative a number is, the smaller it is. Am I right or am I wrong? Of course I'm right. How dare you? Anyway, next. So x squared minus 1. What's going on with this hole? I want you to know something, and then this leads into what we have to do for our notes. Right. The numerator, correct. And then over x minus 1. I'm really upset about that calendar. I'm thinking about it more and more. There's a missed opportunity. All right. And then anyway, sorry. Cancel. Okay. So this is why you got the picture. What is this a picture of? A linear. What do you think the slope of that line is? 1. What do you think the y-intercept of that line is? 1 as well. But look at where the hole is. The hole is located at 1, comma what? Plug in 1 into that new function. What's 1 plus 1? 2. Isn't that located at 1, 2, that hole? This is how you find a hole. After you cancel the factors, are you listening over there? You're doing a lot of fidgeting and shit. And then at the end, how do I do any of this? Okay, I hope you're paying attention. All right. Looks like he's in gym class over there doing some stretching and. All right. Anyway, let's move to this one. Okay. X, right, over x times x minus 2. What happens to the x's? They cancel. Now this makes me sad. Last hour was doing this. What's left up in the numerator? 1. Not what? 0. So there is times 1. There is a 1 up there. So where is this hole located? It's located at, there's the cancellation. This is where the hole is located. But that's the x value. That's what you're supposed to say, by the way. But what is the actual coordinate? It's like f of, you know what, I like calling this a new function. G of x now equals 1 over x minus 2. This graph is identical to that graph, except the first graph has a hole in it. So what coordinate does this have? 0, comma. Well, when I plug in 0, that is 1 over 0 minus 2. What's 1 over 0 minus 2? Negative 1/2. So this hole right here is located at 0, comma, negative 1/2. This is how you find the location of the hole. You plug in the x value into the remaining function after the canceling. And if you don't know how to do that when you go do it at homework, you're licking the walls right now and you're not paying attention. Okay? That's what you're supposed to do. And you can look at that. That does look like it's a little bit below 0. So it's at negative 1/2. Rough. All right? And then are there any other holes? No. So I was trying to show you on this graph, you can see these points coincide with what I found for the location of the hole. All right? And we're going to do that again. Okay, and then more so about the reading. This is exactly everything I'm going to do. Here's what we're not going to do on our homework. Turn to your homework. I think isn't there fumble? I got it. They don't know. Oh, here goes my back. Oh my goodness. Oh, and I missed and I hurt my back more. Ooh. Okay, back up a little bit. Isn't that letter E in your homework? It says find the limits. I don't want you to go into your calculator, try to figure out how to graph these. We haven't done enough graphing yet to do that part. Okay, but what we can do is understand the naughty of the denominator. Like I got to know how to find or determine the difference between a vertical asymptote and a hole. Got it? Okay, because otherwise you'd have to go to your graphing calculator. You don't even know how to manipulate windows. You may not even know how to type it in yet. And I think it's a little out of sorts. And it's a Monday. Don't you want a shorter day? Somebody said something. Only one person. Can't stand your voice. Can you just stop? Can you be done yet? That's what they're saying about me. If you don't know how to factor, then I'm going to throw you in the AB class. And then you can be with all the rest that don't know how to factor, and I'm going to throw a podium up against the wall because of it. All right? They factored in math 2. They factored in math 1. Some of them factored in math 3. They come into my class, I can't factor. Okay, does something cancel? Yes, it does. The x plus 3's. Now, somebody literally asked me last hour, how do you get to a good student? But still, I still have to question it. So where's the hole located? Negative 3. So the hole is located at negative 3, comma. It's the 0 of that factor that cancels. But then negative 3, comma what? And I really do want to name this a new function because it's not the same as the old. It's almost exactly the same. Like if I put these in my graphing calculator, they would look identical, except the original has an interruption. And then actually in your graphing calculator, if you zoom in far enough, you'll see that gap. Doesn't have a big open hole, but there will be a gap there. Maybe with you guys, I'll show you that when we actually graph and pull out the graphing calculator. But anyway, wrong. I'm doing g of negative 3 of that. So it's negative 3 minus 3 over negative 3 minus 4. What is that as an output value? 6/7. Now, we're not graphing it. I'm not going to show you, but you can imagine what would happen because of what happened on our previous page. I hope you kind of get it. I hope you were listening. But then what's this? This is our vertical asymptote. And I'm not going to worry about, I guess what the other teachers are doing is maybe input, say it. They're probably maybe having them put some values right to the right and right to the left of it. But again, that requires that you might have this in the Y1 screen. And I think it's just a little out of order right now. Or I just don't want to do too much today. Maybe I'm just being lazy. And that's it. That's it. That's our 2 points of discontinuity, all based off the idea you can't divide by what? What can't you divide by? 0. That's why 4 is naughty. I plug in 4 right there. I like how that happened. I put a 4 in there. 4 minus 4 is 0. I have a 0 in the denominator. Oh, I forgot to ask you this. Why is negative 3 is 0 when this becomes 0 over 0? That's weird. I forgot to ask you this up here. Little trivia here. What's 0 divided by 0 then? How many people say 1? Raise your hand. Nice. Anyone else? 2. Good. Good, good, good. How many people say 0? Raise your hand. Okay, that's nobody. So we got 2 people on 1. What are you doing with your hand? You're going like this, and then is your elbow? You got a broken arm? Okay. And then how many people say undefined? Raise your hand. Okay, does someone have another answer? Because 3 dang people out of 20 raised their hands. I don't know what the word is. 3 people. Okay, so what do you have if you didn't raise your hand? Go ahead. What do you say it is? You didn't raise your hand once. That's 3 options. I know. I'm stretching over here, and I don't even know if I'm paying attention. Okay, what about you? You didn't raise your hand, did you? One. Okay, that was an option. That's when you raise your hand. All right. Did you raise your hand during that? Let's all start over. How many people say 1? Raise your hand. 1, 2. Oh, we got some more 1s. She just went like this, then went to her earring. All right. So what was that? Okay. How many people say 0? Raise your hand. You have to raise your hand once, or you're suspended. How many people say undefined? You better raise your hand, or you're suspended. He's right. Good for him. Let's give him a hand. Yay. All right. It's undefined. This is so much fun. How many people actually did raise their hand on undefined? I could barely see it though. Some are raising their hand like this, like, and they can't even see what they're doing. It is undefined. Type it in your calculator. Go ahead. Type 0 divided by 0, or your phone, or photomath it. Write 0 over 0 on your paper and photomath it. That's what the kids do these days.
Error.
The phone said error. Look, the phone said error. A photomath. Oh no, you use the calculator. I do want to see what photomath does now. Oh, these kids. All right. Any holes in number 7? Are there any holes in number 7? Are there any holes in number 7? No. So what do we have? We just have a vert-ASI. That's a vertical asymptote. And again, what did I tell you to not do? Don't do those limits before and after. Let's just identify our zeros in the denominator, and then it will be some dotted line. I swear to dog. 1, 2, 3, 4, 5. Dot. You're going to have a vertical line here, and then the graph is going to do either this, like something like this, or reversed. It'll be like, I'll go green here. This is what's going to happen. You just don't know enough information yet why that occurs. Okay, so that's why to the right and to the left, you're going to either have infinity or negative infinity as output values for the y's. All right, so anyway, don't worry about that right now. I think that's a little out of order. Then the last one, and that'll be done. You know what you should do, though? You should take out a -1. Whenever I see a negative on the x value, I don't like it. I like seeing it as a positive initial or leading coefficient. Just determines that I have a -1 floating out there. That would be a flip of the graph vertically. Then on the bottom, I'm going to do this, not to go too fast, and then factor completely. Aren't you glad I took out that -1? Yes, Mr. Samuelis. Thanks, Danny. You're the best student in here. Oh, Mr. Samuelis. That's Mr. Samuelis talking to himself. Because no one else will. Okay. Anyway, those cancel. So what does that make? What does that make that? Oh, and then what is the x coordinate of the whole? Like somebody asked me, I don't know, last hour. I don't know what they were doing. They're a good student though. I just maybe reaffirming. So what's the x coordinate of the whole? 1, the 0 of that. And then what is the coordinate of that? Let's call that like j of x. J of x is wrong. J of 1 is what we're going to find, and it's plugging it in to the new function, which has 2 other parts on the bottom. And wrong. I don't know why I did that. I said it was j of 1, so these become 1. So in the movie sense, you're seeing the input. Say it. You're seeing the input-output action in action. Ooh. All right. And then what's 1 plus 1? 2. 2 times 1? 2. So don't you agree it's -1/2? And then when we actually graph and connect, and you'll see how that fits. It'll crinkle. Okay. We'll see how that fits, and it's a little interruption. And then, oh no, I hope I did this right in the other hour. What are the naughty values for x that I would still plug in and get a 0 in the denominator? 1 is 0. So vertical asymptotes. you'll have 2, which we did not have a representation of that up there, what 2 vertical asymptotes look like. And then x equals -1. And oh my gosh, that'd be 4 limits you'd have to write if I kept that in there. Because at 0, left and right of 0, and then at 1, -1, left and right of 1, -1. Keep missing that negative. Okay? So know the difference between whole. Hey, get those highlight. Oh my gosh. With my math, we're doing a lot of coloring in math, or in the AB class. We're doing a lot of highlighting to show where the parts of the equation create certain issues in a rational function. So get your highlighters ready when we get into the, graphing of those. As a matter of fact, I made a brand new worksheet for them Thursday. I think I'm going to use the same one for you because it worked out so well. But anyway, nobody cares about that. Okay, bye on a Monday. Go Bears. They actually won a game.